I'd like to introduce Michael Lissack, who is our first speaker this morning, who's going to give the Randolph. Michael is the current president of the ASC, and we are hoping for great things from him. He is the executive director of the Center for Coherence and Emergence. He came out of a quite storied career in business to enter the field of complexity, corporate anthropology, emergence. He founded a study or group. He has organized an EPI resource for scholars to find resources without having to turn themselves inside out. He is a visiting professor at Hull, an affiliate professor at Boston University, and a number of other visiting tracks here and there. And we are very happy to have him. I'd like to just say a couple of words about Ranulph. We all miss him. He should be here. It's a great pity that he is no longer with us. He was an inspiration for many. He was extremely generous with his time, his attention. He traveled all over the world. He wrote hundreds of articles. He inspired and worked with students, from Australia to Hong Kong to Europe to fairly recently, we saw him in Toronto at OCAD. And I have a very small personal bit of gratitude to him, because when I was a doctoral student trying to figure out how to deal with data where people were using had different meanings for the same words, and in about a dozen words he said, "Oh, go talk to Millie Shaw. She's doing work with Repertory Grid of George Kelly." And in about a dozen words in a conversation for about 2 minutes, Ranulph handed me a methodology. And I'm sure he didn't even know it. At any rate, we remember him with respect and affection, great affection, and Michael will now come up and give the Ranulph Glanville lecture. Thank you.
Technical difficulties, please stand by.
Just come over here, please. Which ones are you using? Yep, on the team. Yeah.
Great. Okay, does anyone recognize the picture that's up here? Good, would someone tell me what it is? It is indeed the ENIAC. And you might say, why am I starting this talk with a picture of the ENIAC? But the ENIAC, while it was the thing that heralded great things and brought us into the computer age, is also a symbol of something that has brought us other issues. So in our computer age, we are focused on things that can be done by a computer. Computers insist on accurate, fixed meanings. Computers insist on direct causality. And I'm going to keep coming back to those two things, because the fact that we are so dependent on a computer has shaped how we see the world. So ENIAC is there not only as a computer, but also as a symbol of something that has changed how we view the world. All right, it's a Michael Lissack talk, even though it's also the Ranulph Glanville lecture. So you have some things that you need to do. Would everyone please get out a piece of paper and a pen? It is important that you play along with me at least and draw a picture of the Earth. You're not getting graded. It's not a, this is not art. It's on test.
It's free.
Okay. Next assignment. Please draw a picture of houses on the Earth. Great. All right, one more. Only one more. All right, one more. Only one more. A picture of people on the Earth. Good. All right. Could people hold up their pictures of the Earth to show one another? I'm assuming some of you drew something that was something like this. Okay. Could you hold up your picture of houses on the Earth? Same picture's fine. Did you draw this one with a nice sort of flat Earth with houses on it? Or did you draw this one? This one. Neither. What did you draw instead? I can't see from there.
I have the Earth embedded within the multiverse.
Okay.
And then I have the constituent parts. So it's.
All right. Could you hold up your pictures of people? Did you do people flat on the Earth, or did you all have people round about the Earth? All right. Can I point out that when you drew this one, these people are extremely large, and it's not quite clear how our planet has 7 billion of them. They don't really fit. Okay, so what was the point of doing all of that? The point of that was I gave you simple instructions and you came up with multiple meanings. So in contrast to what ENIAC likes, in contrast to what the computer likes, we live in a world that is filled with ambiguity. And guess what? Courtesy of ENIAC and the computer, we don't like ambiguity. So it would have been nice if you all drew the same pictures of the Earth and the people in the houses, but you didn't. So, why don't we like ambiguity? We live in a world that makes extensive use of data. And we at least like to pretend that the data has fixed meanings. Because if it has fixed meanings, we can do numerical analysis and statistical analysis, and we can do reduction and summarize and all these nice things that don't work if we treat the data as having ambiguity. And we like being able to play with data. Reason number 2, we're very used to direct causality. And if you've got direct causality, it works. Many things work. The air conditioning works, the lights work. The coffee machine and the juice machine didn't work so well this morning. But anyhow, causality is another reason why we don't like ambiguity, because it screws up our understanding of causality. And then reason 3 is, hey, when we treat things with fixed meanings, when we say they're simple and directly causal, most of the time the world works pretty well. And we like success. Success is really good. It makes us feel good. So ambiguity is bad because it screws up our notion of succeeding. All of that is great, but, and it's a big but, success in this part of is only in a small part of the world. So if we stay focused in this little simple part down here, we can ignore ambiguity, we can make use of fixed meanings, we can have direct causality, and all is well. But it's only a small part of the world. There's a whole rest of the world out there. And just like the computer isn't good with the rest of the world, and the poor Google car can't deal with humans, we still have to deal with ambiguity. So what's going on? There's a few simple lessons that we need to get across. One, complicated and complex are not the same. People tend to use them as if they're the same, but they're not even close. So the root of complicated is plick. Plick means to fold. Things that are complicated are folded up, and when you need to find an answer, you unfold them till you get to the plane that contains the answer, which is why I've got the metaphor there of the map. Complex has a different root. Both have the com, which means with, but the root of complex is plex, and plex means to weave. You cannot unweave something that is complex to get to its answer. When you do that, it's just like the old high school biology lesson of dissecting the frog. Good luck putting it back together. So you have to treat complex things differently. All right, lesson 2. Ambiguity and uncertainty are not the same thing. Ambiguity is when we have multiple meanings present at the same time. Uncertainty is when you're not certain. And that actually is when you do not have a willingness to act. When you have so much information or so much confusion that you are doing the deer in the headlights routine. And again, we live in an age where these two words have gotten confused and slammed together and treated as if they're the same. But they're not. They have very different roots. They have very different meanings. We live in a world that has indirect causality. Even though the media doesn't tend to portray this very often, most of the things that happen in the world do not happen because A causes B. They happen because we live in an environment E. A and B do whatever they do in environment E, and then something changes, and E becomes F. And now the relationships between A and B get a little bit screwed up, and something else happens. You cannot portray that by saying A does B. Something else is going on. But again, the modern media tends to ignore that. That's not the easiest way to tell a journalist story. A computer doesn't like that because it's not the easiest way to program an algorithm. But it's critically important. So the last and probably the most important thing is we have way too many choices. You go into the supermarket today and you can find, at least in the United States, a couple of hundred different versions of yogurt. Do we really need to have to decide what to do with the yogurt? I will tell you, my mother goes to the supermarket. She is told by my sister to bring home yogurt. She spends 15 minutes staring at the yogurt case because she does not want to get my sister upset if she brought the wrong one home. We have way too many choices. So the question is, how do we deal with all this? And we don't necessarily deal with it very well. What we do is we cope. So here's a little bit of pragmatism. And I know many of the people in the room are scientific realists, and I happen to be a form of a pragmatist, so you're going to have to put up with it. Where knowledge is not a matter of getting reality right, but rather a matter of acquiring habits of action in order to cope. And coping is our key technique. That's what we do. How do we cope? Well, most of the time, we create our own reality. We don't deal with what is, we deal with what we perceive. And sometimes what we perceive has nothing to do with what is. All right? So we tell stories, and what goes on in our head becomes how we process the rest of the world. And the way we tend to do this is that we filter. So there's lots of choices. Well, you can't deal with all of them. So the first thing that we do is we limit our field of attention and we narrow our context. And then that's not good enough. We still have way too much to deal with. So now we limit the factors that are being considered and we introduce some boundaries and constraints. Then we sort of are prediction machines. What's going to help us? What's going to help us with the next step? So we predict things and we filter again in order to create reality. And then finally, we choose among our predictions. And when we do this, we produce the inner stories that we tell in order to make things work. Now, we're after clarity. Clarity is not always possible. Clarity tends to be unavailable from the things that we teach at school, because we teach that you should always be rational. Rationality outweighs emotion. That if you can label something, that's more than good enough to use it as a model. So once I know that I've got a chair, fine. All chairs behave like X. Well, they don't, but that's what we teach. And then finally, multiple perspectives, well, that's unnecessary. If you take in multiple perspectives, you're complicating your life. Why would you want to do that? So what we teach does not necessarily help us. So instead, we treat representations and labels as if they were the things that were being labeled. Much easier to manipulate a representation. And again, in the computer world, we all get represented as some series of data that gets manipulated. We are a piece of data in some consumer cluster that the marketing people use in order to decide what to assign to us. And if you happen to have a modern version of one of these, there are many department stores that you walk into, and if you happen to have it on, well, the data gets triggered. And now the department store knows that customer who likes blue jeans has entered the store and can react accordingly. And I've got news for you. The supermarket, if it's a sophisticated supermarket, has been doing this to you for years. There's a sensor built into your shopping cart. It knows where you are and knows where you stop. So now I've got to switch to the things that are not necessarily so easy, because again, the joys of being an applied philosopher, there's always something complicated that I've got to show you. And for Mr. Kinnaman, who's in the back of the room, he will like this, because this is the really important thing. All right? And I'm going to tell you that a key to understanding all of this mess is to understand Rosen's modeling relation. And I'm not going to give you a John Kinnaman hour on what this all means and how it all works. John's here, he can do that. I'm going to do the 30-second version. All right? And in the 30-second version, what is important? The thing that is important is the encoding and the decoding. It's nice to have a natural system. We can observe the natural system. It's nice to have a formal system, those representations and labels. But what matters is that you need to be able to go back and forth. And you go back and forth with an encoding and a decoding regime. So what is encoding? Encoding is something that allows a perceived item to be converted into a representation. And let me give you an example. I don't know if you could read this, but this guy says, my poop joke got retweeted. I'm a success. And this guy says, my novel has only sold 300 copies. I'm a failure. So this is how they are encoding the realities that they are dealing with. But of course, I had you guys do an encoding exercise. You drew houses on the earth. That was an encoding exercise. All right, now what is decoding? So decoding is taking that representation and turning it into something that actually can be used. The computer can use the representation, but good luck driving the data equivalent of a car. You actually have to drive the car. So, again, we have an example of a decoding problem. All right, so The goal is, if we can learn to question the encoding and the decoding regimes that we are using, we can better deal with ambiguity and can better deal with complexity. So, if we do this, we can build upon the things we already have. I'm not asking you to learn something completely new. I'm asking you to ask better questions. And the questions are about the encoding and the decoding that's going on. If you do this, magical things happen. So you can't stand up here and give a lecture that's supposed to be 45 minutes or an hour and not give you a how. So here's the how. All right, so the basic assumption that I want you to question is that more information will lead to better decisions. That is certainly often true in the simple part of the world. But as the example of this really interesting Swiss Army knife, sometimes more is more, and it's not better. It's just more. I wouldn't want to carry that thing around. And by the way, that is a real product, and if you were to go to either of the two main department stores in the city, you can buy one of those. I found one yesterday. The truth is, much of the time we deal with multiple meanings. So again, I'm not sure what people can see, but the first two, we've got two meanings of the word fly. We have two meanings of the word tier. We have two meanings of the word train, two meanings of the word wave. If you use the word without context, it is ambiguous. The meaning is derived from the context. That means that you've got to go through an encoding and decoding routine in order to figure out what's going on. You can't just look at it and say, I know what tier means. You need context. Now, there's more than one person in this room. And because there's more than one person in this room, what happens? You see something that's ambiguous, and both, at least two people, have two meanings. If there's 200 people in this room, there's at least 200 meanings. You all have your own context in your head. Yes, we're all sitting in this room where I'm standing. But you've got the context where you came from, your personal history, what you've learned, quite frankly, what you ate for breakfast this morning and what you are or are not remembering right now. All of that affects how you will interpret things. And what tends to happen when people have two different meanings? And remember, we're here talking about the Anthropocene, and there's lots of people, when they hear the words climate change and global warming, in the absence of context, derive their own meaning. And guess what? That's what tends to result. So there's a lot of people that may think it's the same thing, but there's also a lot of people who think it's very different. So these two words, by themselves, in the absence of context, are ambiguous. And if you don't think they're ambiguous, you're fooling yourself. All that's going on is you have a personal context that you are applying to the words. So you are now taking the words against your context, you are encoding them into something that makes sense for you, and you are assuming that everyone else will decode it the way you do. And as my mother always taught me, never assume it makes an ass out of you and me. And that really applies in this case. All right, so if everyone agrees, you get this nice 45-degree line that they tend to teach you when they're teaching you communication theory. So we have acceptability. Do people perceive that the other person's position is acceptable and they're willing to engage in a discussion? That's our vertical axis. Our horizontal axis is similarity. Are you guys perceiving that you're talking about the same thing? And if everyone has a high degree of similarity, then their acceptability will be the same. And when you're all on the same page, it's great, and more indeed is better. Okay, let's look at the climate change data. So this graph is a normal graph, And you will notice that what people perceive, if you come from a certain point of view, is the average trend is clearly up. It's a very compelling graph. Temperatures are increasing. Is there anyone who sees something other than that in this graph? Okay, now I'm going to take the same graph and watch. Please notice that if you aren't plotting a uniform trend and instead you are plotting trends over smaller time periods, it is not at all clear that in any given smaller time period that the trend is up. The overall trend is still clearly up, but in each of these time periods, there's some flatness. If your context is this, you talk about global warming and everything seems obvious. If your context is on a smaller scale, and you talk about global warming, you're like, well, yes, but there's intervals where there's other things that could be done, because yes, the overall trend is up, but we've got these nice flat periods. Flat periods give us the opportunity to do things. So how do we deal with the fact that there's both points of view? And there's a graph I want to show you, because it basically is what happens. That nice 45-degree line that you showed is great up to a certain point. And then more is no longer better. More means that each of you digs into your own position. The encoding and decoding regime that you use makes no sense to the other side. And you plunge into what I'm going to call the chasm of dissonance. And you know that an argument is in the chasm of dissonance when down here, people stop talking about the content at all. And all they want to talk about is how evil the other people are, how bad the other people are. Because talking about content is useless. The more evidence you present, the more dogged people get into their own positions. You can't fix being in this chasm with more is better. It just doesn't work. But there are strategies for what to do. So here's our options. We could just get stuck. That's option 3. And we could keep talking about how more is better, and it doesn't work. And we'll just keep referring to each other as evil and awful. And in the United States, this happens with people who talk about abortion. It happens with people who talk about gay marriage. It happens with people who talk about global warming. It happens with many things. So complexity theory says that you could try option 1. Option 1 is to opt for greater abstraction, to bring back in ambiguity, to move this way out of the chasm. Less information. Use an abstraction that creates more room. Project management and that kind of point of view suggests that there's another solution. Their solution is option 2. Keep adding constraints until you get a narrow, focused context where whichever point of view it is you're trying to get accomplished is the only one that makes any sense. So if I go back to my graphs, if I want to talk about long-term trends, this graph makes much more sense than this graph. If I want to talk about how much time do we have to try to do something, well, now this graph may make more sense. There's a narrow context, and the narrow context helps define which encoding and decoding regime might work better. Okay, now, we have a little problem here. You notice I have portrayed a rope bridge. And rope bridges are not really the most stable things in the world. And if you come at them with a lot of baggage, they don't work really well. The rope bridge is option number 4. This is what you find asserted in the media almost all the time. Journalists can't help themselves. Now, for those that are social scientists in the room, many social scientists make the same error, and they shouldn't. So what is this error? You find the case using option 2, you have imposed constraints so that it's clear that there's one encoding and decoding regime that makes sense. Having found that narrow context, you now assert that it's the general case. When I was getting my PhD, we used to refer to this as the error of the sample of one. And the worst version of it was when the researcher decided that they were the appropriate sample of one. So the narrow case gets asserted as general. And you see the media doing this all the time. So they take the enabling constraint and they now assert that it's an abstraction. They have built a rope bridge. And when they're very nimble and you're very young, you can get across. But most of the people who come with a lot of baggage are going to fall right back into that chasm. So let's again look at climate change. The media sees an example like this and it says, aha, it's clear. Extreme weather events mean that we're on a particular part of the curve. I've made my argument, case proved. Maybe. So if you look at what's happened, you see temperature just by itself. And yes, the temperature is going up. It's not going up at all as fast as most of the models predicted. You could revise the models if you like. But it is going up. So that's, there's a case. But because it isn't going up as fast as the models predict, we still have this little problem of people disagreeing. Now, let me give you a different graph about which there's no disagreement. If I plot temperature change and temperature against CO2 concentration, and I narrow the question to something that actually is narrowly defined and almost non-arguable, you can see that as CO2 concentration has gone up, temperature has gone up. It's very clear. If your concern is temperature, you need to be concerned about CO2. That's a narrow question. It is not the same as using those magic words, global warming or climate change. It is a narrow question about CO2. If I say this, I get that chasm of dissonance with many people. If I say this, it goes away. All right, so we get models like this to assert that the CO2 part of the model, which is here, is right, which is what that graph showed, does not mean that all the rest of this model is right. And we actually have no basis of asserting that. But the media will assert, well, I've proved this, so therefore all of this is right. This is all assertions. This is somebody's model. A modeler decided these things. They were not just handed down by God. Now, there are implications. So this is one from Western Australia. Use the prior model, and it tells you what to do. And you notice that when I look at this model, I have a hard time, other than right here, seeing about the CO2 stuff. All of it is confusing inputs and outputs. We don't know when the water shortages will occur or how. We don't know when the temperature increase or how much. We have absolutely no proof about more extreme events. And this will happen, but we don't know when. So the only one that we actually have any control over, the one that man can do something about, is this one. But that's not what's on this chart. And then you want to know what happens. Well, what happens in the US is people sometimes believe it and sometimes don't. When you talk about the narrow case, it's hard to argue with. When you start making the more global assumptions, it becomes easier to argue with. Ambiguity is not climate change's friend. If you want to make the argument about climate change, you need to be talking about CO2. That's the one piece of hard, incontrovertible evidence. And if you talk about CO2 and what man does with CO2, you are talking about something that actually we can do something about. There's a reason to talk about it. If you want to talk about sea level rises, We can't talk about that in any meaningful way other than saying we need to prepare. We don't have any control over that. You want to talk about extreme weather events, the same thing. We could talk about insurance and how we might prepare. Preparation is always good, but we don't have any control. So now you get to some other models that try to reflect this a little better. And you'll notice now, instead of defining outputs of potential climate change, it just says climate change has impacts. And now it says, let's prepare. There are impacts. How do we deal with those impacts? This is a much easier model for people to accept because it doesn't demand that you ignore the chasm of dissonance. Or we could do another one. This one is about the health impacts of climate change. And again, this is an easier one to deal with because you're talking about things that are within human control, that humans know they can impact, and you're not asserting this general fear that climate change is going to do blah. You're being very specific. If these things happen, it causes these indirectly, which leads to these, which can lead to that. And it's a nice model of indirect causality. So, my lessons for you. If you don't examine encoding and decoding, all you're doing is building a rope bridge. And rope bridges are dangerous. Now, most of today, at least in ASC, is going to be about second-order science. And second-order science can help turn rope bridges into something else. If you run the localized experiments many times before you try to build that rope bridge, you can learn things. So you could collect metadata and see what is working and what's being ignored, and use that to help you turn the rope bridge into something else. You could look at uncritically examined presuppositions that are controlling the experiment and see whether there's something there that could be fiddled with that might change the rope bridge. Or you could find some orthogonalities, which are things that are perpendicular, not in conflict, not in agreement, but perpendicular, that may make all the difference. So let me show you. So if you collect metadata, you might decide that, gee, there's an area that's being ignored. And now you need to ask, why is it being ignored? Is it being ignored because we can't study it? Is it being ignored because we don't know anything about it? Is it being ignored because we don't care? Those are very different. They will affect the bridge you build. We can look at those uncritically examined presuppositions, and you'll notice that the young lady is talking about something that is clearly a presupposition. And then you could try to find the orthogonalities that help. If you're going to go build a suspension bridge, it's funny, the bridge surface works this way, but what holds it up works perpendicular to it. And if you didn't have those orthogonalities, you couldn't hold up the bridge. And again, we're trying to reinforce a rope bridge. And again, we live in a world of ambiguity. I'm assuming everybody has either heard of this movie or seen it. And we're at a systems conference, so I will give you systems ambiguity. When you use the word systems, there are at least these two meanings in this room. And don't kid yourself to assume that everyone has the same one in their head. They don't. Many of the ASC people have the second one. It is a different meaning than the first one. And what happens? So when that happens, what do you do? Again, we've got four options. So, dealing with ambiguity is like building a bridge. I would suggest that we would prefer a solid bridge like this to the rope bridge like that. You get there by making questions. So you could start by putting in some islands of stability, which is those local experiments that narrow context, the incontrovertible evidence. that is only incontrovertible because you've narrowed context. You've imposed constraints and boundaries. And when you then try to generalize, you have to talk about the constraints and boundaries that you impose to make it work. If you ignore them, if you stop talking about them, all you do is take the pillars out underneath. And that doesn't work. Or you could begin with an abstract idea and try to figure out how to fill in underneath it. That's also a way to do it. But at least agree that you're starting with something abstract and you don't know what fills in underneath it. If you don't examine encoding and decoding, you may end up drowning in the chasm of dissonance. And the choice is yours. And I couldn't have done this without the inspiration from one of my mentors and people who guided me a lot. So, Ranulph, wherever you are, thank you. And that's the end of this. Thanks.